Okay, here's our examples on sketching a parabola using the technique completing the square to help us find x-intercepts. We've got three examples today. Example 1, we're asked to find the graph of y equals x plus 2 all squared minus 9. You might note that this is already in the turning point form for us. How do we sketch a graph like this? First thing we find is the y-intercept. We put 0. So I'm going to replace this x here with 0. So it becomes 0 plus 2 all squared take 9. So the brackets then becomes just 2. 0 plus 2 is 2 squared take 9. 2 squared is 4. Take 9 makes minus 5. So the y-intercept is 0, negative 5. Next thing we find is x-intercepts. We put y equals 0. So we write the rule, which is x plus 2 all squared take 9, and we say it's equal to 0. We've got to look at what we would use here. Here we should note that it's the difference of perfect squares, because 9 is 3 squared. So it stops. The technique for dops is a take b, a plus b. If it's a squared minus b squared. So what's squared here is x plus 2, what's squared here is 3. So using that identity, x plus 2 is the first thing in each bracket. I have a minus sign and a plus sign following that. And what is 9? 9 is 3 squared, so we put the 3's there. Each of these brackets can be tidied up. The first bracket plus 2 minus 3 is the same as negative 1. And plus 2 plus 3 is the same as positive 5. Using the null factor law, we get x is equal to 1 or x is equal to negative 5, which leads us to the saying the x-intercepts are 1, 0 or negative 5, 0. Next thing is to find the turning point. The graph's in the turning point form. Our technique here is to look at the rule and say, okay, we do the opposite of what's in the bracket, so it'd be minus 2 and minus 9 for our turning point. We didn't need to find the axis symmetry to find the turning point, but the axis symmetry is x equals to negative 2, because the x value of the turning point. Remember, the axis of symmetry is an equation, so we need to write it as x equals negative 2. So now I can plot my parabola or sketch it, and the key points that we need to show here is the y-intercept of 0, negative 5, turning point of negative 2, negative 9, and our two intercepts of negative 5, 0, and 1, 0. Alright, we'll move on to example 2 now. In example 2, we're asked to sketch the graph of y equals x squared plus 6x plus 15. This is in the expanded form, there's no brackets involved, it's not the turning point form, it's one of our trinomials. So we still go through the same procedures. We'll get the y-intercept first, put x equals 0 with the rule, so 0 squared plus 6 times 0 plus 15, so 0, 0 plus 15, which is 15. Remembering we'd already learned the shortcut that if it's in expanded form, no brackets, then the y-intercept is the end number. So it's 0, 15. The x-intercept is where y equals 0. So we write the rule and equate to 0. Normally our first attempt when we see a trinomial is to see what factors of 15 could make the middle term. 15 and 1 can't make 6. 5 and 3 can't make 6. So I can't do that easy factorising step by inspection. So then I'm left with the option of completing the square or using the quadratic formula. This demonstration is all about completing the square, so we're going to use the completing square technique. The method for completing the square was you write the first two terms, then you're going to add a number, something squared, that will make this a perfect square. The plus 15 is still there, but to keep the equation in balance, because we've added that squared, we need to take it away also. How do we determine this number? We're going to add and subtract. We look at the number in front of the x term, 6, we halve it, which is 3, so we add 3 squared and take away 3 squared. The first three terms here make the perfect square, x plus 3 all squared. Y plus in the brackets because it was plus in front of the x term. The last two terms, the plus 15 and the other thing we took away squared, we combine those to make a single number. 15 take away 9 makes plus 6. In example 1, at this point, we had a negative sign here, and we use the technique of DOPS, because DOPS stands for difference of perfect square. This is not the difference of perfect square because it's a plus sign. So it's not DOPS. And if it's not DOPS at this point, you will not have any x-intercepts, which creates less work for us. When we draw the graph, you'll see why there's no x-intercepts. The turning point, we can determine the turning point from this step here. When we've completed the square, it's in the turning point form. That's the whole reason for learning the completing square technique, is to be able to write a parabola in the turning point form. We then look at inside the bracket, we do the opposite, so it'd be -3 and +6 would be the turning point. The axis symmetry would be x equals -3 because it's the line that goes through the turning point, the vertical line, so it's x equals -3. So if we sketch our graph, this graph here has the y-intercept of 15 and the minimum point of -3, 6. How do I know it's a cup shape? Because when I look back at the rule here, it's positive x squared. So it will be this shape, cup shape. So at this point, the turning point will be a minimum. Let's go on to example 3, which has a bit more work involved. This one here, another trinomial, x squared minus 3x, take 1. First step, to find the y-intercept, where x equals 0. Put 0 into the rule, which we could have cut out all this working out if we recognise that this n number, because there's no brackets involved, is the y-intercept 0, -1. Now, the x-intercept here has a bit more work than the previous example. Here we put y equals 0. It's x squared minus 3x, take 1. I look at the factors of 1. No, 1 and 1 don't make 3. So therefore, I've got to go through the process of completing the square. So we set it out like this. We're going to add a number in the bracket, squared, and also take it away. How do I determine that number? I look at the number in front of the x term, it's 3. So it becomes 3 on 2. Don't write it as a decimal or as a mixed number. Better off writing an improper fraction, like 3 on 2. Because I add 3 on 2 squared, I need to take 3 on 2 squared to keep it balanced. So the first 3 terms make the perfect square. It becomes x. Take, in this case, because of the minus in front of the 3x, whatever number we added here, in this case it's 3 on 2. How do I get this -13 on 4? There's 2 techniques. You can use one, but the easiest one for you is to use your calculator. You'd need to type this in as -1, not -1, -1 minus bracket 3 on 2 close bracket squared, and it will give you that answer. If you're going to do it manually, you need to work out this bit first. It's 3 squared is 9 on 2 squared, 4, so it's 9 on 4. 1 therefore would be written as 4 on 4. So -4 on 4 minus 9 on 4 makes -13 on 4. When we get to this stage, after completing the square, we need to see if we can use DOPS or not. And that's to determine if there's a minus sign here between the square bracket and the number term. It is in this case, so I can use DOPS. And DOPS says that minus the square root of this, then that plus the square root of this. So x take 3 on 2 starts each bracket. One has a negative, one has a positive. How do I get this here? Well, square root of 13 is square root of 13. Square root of 4 is 2. Using the null factor law, in both brackets, that 3 on 2 will become positive 3 on 2. This will become positive root 13 on 2. This becomes negative root 13 on 2. You might remember from our completing the square work, we did that short step. Actually, we learned how to go straight from there to there. That leads to the 2 x-intercepts. We've got one is 3 on 2 plus root 13 on 2, comma 0, and 3 on 2 minus root 13 on 2, comma 0. If I put that on my calculator, it'll come out to approximately about 3.3, and this one comes out to approximately about -0.3. That will help me when I have to sketch my graph. I work out the decimal values. We also need to find the turning point. We go backward a step, which here it is, and we look at the bracket. We do the opposite sign what's in there, so it'd be 3 on 2, comma, negative 13 on 2. Negative 13 on 4, sorry. It'll be negative of that, so it becomes positive 3 on 2 and negative 13 on 4. So now I've got enough information to sketch my parabola. The axis of symmetry is x equals 3 on 2. You note back here that the x-intercepts are symmetrical about that line. So both got 3 on 2. One goes positive 3 on 2 to the positive root 13 on 2 to the right, and then one goes, you subtract negative root 13 on 2, and you go to the left. So when you see the sketch here, we've got our local minimum, which we get from the turning point. Once again, it's a cup shape because it's positive x squared. Our y-intercept, we work back here, is 0, negative 1, always generally the easiest thing to work out. The x-intercepts are for these two ones here. So the first one, the positive one, so here's 3 on 2 plus root 13 on 2, approximately about 3.3, as I said before. And this one here is 3 on 2. I've now got to take away root 13 on 2, and that's where that point would be, and that's approximately about negative 0.3. A little bit more, but I'm not going to be too fussed about that. Okay, thanks for going through this, and you'll now do the exercise questions in your work plan from exercise 7D.